Earth atmosphere, high oxygen atmosphere, wetland forests, and giant arthropods, yet brought unexpected global consequences. Carboniferous wetland forests covered vast equatorial regions. Giant lycopods and scale trees created unprecedented biomass. Vast amounts of plant debris fell into anoxic swamp waters. Microbial decay was slow. Carbon was progressively sequestered rather than returned to the atmosphere. Microbial decay was slow. Carbon was progressively sequestered rather than returned to the atmosphere. Periodic sedimentation and sea level changes buried peat layers underground. Pressure and temperature slowly converted organic matter into lignite, then bituminous and anthracite coal. Pressure and temperature slowly converted organic matter into lignite, then bituminous and anthracite coal. This process continued for tens of millions of years, forming today's major coal fields worldwide. Carboniferous carbon sequestration was an unprecedented withdrawal in Earth's carbon cycle. Carboniferous carbon sequestration was an unprecedented withdrawal in Earth's carbon cycle. The forest's growth and burial simultaneously laid the foundation for rising atmospheric oxygen and future energy reserves. Meganeura dragonflies reached wingspans of 70 centimeters, the largest known flying insects. They hunted other arthropods above the Carboniferous forests. Oxygen molecules diffused efficiently in the giant arthropod tracheal systems. Muscle tissue delved deep. The lens advances into the chest and wing muscle interiors, contrasting the diffusion limit in modern 21% oxygen air. Giant myriapods, such as Arthropleura, moved across the forest floor, exceeding 2 meters in length. Abundant detritus supplied ample food. Abundant detritus supplied ample food. Elevated oxygen supported not only giant flyers, but larger arthropod communities overall, in canopy and on ground. Predator-prey dynamics unfolded in this distinctive atmosphere. Predator-prey dynamics unfolded in this distinctive atmosphere. This age of giant insects was a brief window of specific high oxygen and high productivity conditions. As oxygen later declined, giant arthropods became constrained. As oxygen later declined, giant arthropods became constrained. Carboniferous plants drew down vast amounts of CO2 from the atmosphere via photosynthesis. Organic carbon buried in swamps was removed from the biogeochemical cycle for the long term. Organic carbon buried in swamps was removed from the biogeochemical cycle for the long term. Long-term carbon burial caused atmospheric CO2 to fall, driving global cooling and glacial expansion in the late Carboniferous early Permian. This carbon starvation altered climate patterns. This carbon starvation altered climate patterns. Coal fields formed in the Carboniferous became the primary energy foundation of the Industrial Revolution. Carbon sequestered for hundreds of millions of years was released back into the atmosphere in mere centuries. Carbon sequestered for hundreds of millions of years was released back into the atmosphere in mere centuries. Carbon cycle models, Berner et al., and paleo-atmosphere reconstructions, Glasspool and Scott, show the Carboniferous oxygen peak closely tied to burial rates. Evidence comes from coal seam thickness, plant fossils, and sedimentary records. Evidence comes from coal seam thickness, plant fossils, and sedimentary records. Carboniferous sequestration both shaped later Ice Age climates and supplied critical fuel for human industrial civilization. It is a multi-layered, delayed, and contingent geological legacy. Carboniferous sequestration both shaped later Ice Age climates and supplied critical fuel for human industrial civilization. It is a multi-layered, delayed, and contingent geological legacy. Coal seam thickness, plant fossils, and giant insect wing impressions provide direct evidence. They indicate an anomalous peak in Carboniferous biomass and oxygen productivity. They indicate an anomalous peak in Carboniferous biomass and oxygen productivity. Scholars continue to weigh different drivers for the oxygen and coal peaks. Plant lignin evolution, anoxic swamp preservation, and tectonic accommodation space likely operated together. There is no single decisive cause. Plant lignin evolution, anoxic swamp preservation, and tectonic accommodation space likely operated together. There is no single decisive cause. Paleobotanists, geochemists, and paleoentomologists work in the lab and on computers using isotope analysis, 3D imaging, and carbon cycle simulation. The camera moves between field, lab, and computer workspace. Clean, professional process. The camera moves between field, lab, and computer workspace. Clean, professional process. The high oxygen and giant arthropod window was transient. Subsequent oxygen decline and Permian environmental changes restructured terrestrial ecosystems. Many giant experiments did not persist long-term. The Carboniferous coal forests and high oxygen atmosphere were the product of multiple contingent factors in the Earth system. They provided foundations for later climate and energy, while reminding us of the profound and unpredictable consequences of carbon cycle perturbations. They provided foundations for later climate and energy, while reminding us of the profound and unpredictable consequences of carbon cycle perturbations. Carboniferous carbon sequestration altered atmospheric composition and set the stage for subsequent climatic upheaval. When the Siberian Trap's large igneous province began erupting, the carbon cycle balance built over hundreds of millions of years was shattered. Global History, Episode 007, the Permian mass extinction.